Okay, so let's look at the first law. That is the law of dominance. So when two homozygous individuals with one or more sets of contrasting characters are crossed, the characters that appear in the F1 hybrid are the dominant characters, and those that do not appear in the F1 are the recessive characters. Okay, so simple enough from what is already written. Okay, when one individual, okay, is crossed with, okay, when one homozygous individual is crossed with another homozygous individual, okay, so these are the parents, okay, the characters that appear after crossing are, okay, so, okay, there, all right, the characters that appear, if this one is for, let's say, tall, and this one is for dwarf, okay, the character that appears, the phenotype that appears in the F1 generation is that of the dominant one. That is, they will appear tall, okay, because the tall gene is dominant to the dwarf gene, okay, so simple enough, okay. So we can say that the character which is tall is dominant and the character which is dwarf is recessive because dwarfness did not appear, okay, in the F1 generation. Very simple. So here, that same cross that I did by hand, okay, so you crossed, here you crossed, here the cross is like this. The female is having BB and the male is having BB, okay. Then they will assort independently. Capital B will go differently to small b, capital B again will go differently to small b. Then this one, okay, will go here. So capital B, then capital B will go with small b there, okay. Then now small b will go with capital B, so there, and then small b will go with small b there, okay. So you are getting three three purple appearing plants and one white appearing plant, okay. So you can say that the gene that is for purple color is dominant to the gene that is for white color. So the law of dominance says that if the two alleles that code for the same trait means appearance, okay, the one that appears is the dominant and the one that does not show or appear in the organism is the recessive one, okay. So now let's see the explanation. The dominance and recessiveness of the genes can be explained on the basis of the enzyme functions of the gene, okay. So let's say the dominant gene is functional and it produces proteins. This is long polypeptide which gives you the color purple, okay. While the recessive gene, when it codes for when it goes under transcription, translation, all those you will do with Ms. Dihun, when it undergoes that and produces the polypeptide, something is wrong with this polypeptide, no? That is not able to give you the color white, okay. There's something fail here. That's why it's recessive. So this is a simple explanation that it could be because the dominant one could produce the functional polypeptide and the recessive one was producing incomplete or non-functional polypeptide, okay. So the protein does not show, okay, does not show the white color because there was something wrong with it, all right, non-functional. So therefore the dominant gene produces a specific phenotype while the recessive gene, it will fail, okay. So in the heterozygous condition Also, the dominant gene is able to express itself so that the heterozygous and homozygous individuals have the similar phenotypes. So it's very easy. Okay. So we have appreciated this law because scientists, they have done the crossbreeding experiment, and we find out that it is applicable. Okay, it is practically applicable, what he thought and what is done. All right. So now the importance. What is important about finding this law is because there are some harmful and dangerous characters that are masked, okay, by the dominant one. Let's say this recessive gene, C prime and C, it gives the person blindness, okay, blindness, color blindness, not fully blindness, but color blindness. Okay, so wouldn't we all want to see color? Come on, no, it's so beautiful, no, the flowers, you know, the sky, let me tell you a story, you know, about my mother. My mother had a best friend. Okay, he is not a best friend, but a good friend. No, he is R.C. Lalu. Right now, he is a very powerful man. Okay, he's R.C. Lalu. He is a professor in Nehu also, and he is an MLA also. No, so they were when they went for the medical checkup, no, to get a medical seat. After finishing all the medical checkup, in the color blindness part, he was in the front position, no, and my mother was just after him. He was, I think, he got 5th position, all state, and my mother, I think she got 6. I don't know, 6 or 7. Okay, only I don't know. So just before getting the medical seat, no, when they did him the color blind test, he could not see those numbers. No, some of you have attended, I think, when you went for. When you tried for your medical entrance, no? So he could not see the colors in that color blindness test. So he lost that medical seat, but still he became great, no? Then he had to go for normal BSc like you and me, and then he did his masters, he topped. Then he did his PhD and he became a professor, and then he became an MLA, and my mother was just a normal doctor, nothing more, no, nothing great. Okay, just a normal doctor, and he is he's a professor, no? So everybody wants to see color, right? Everybody wants to see, right? So what I'm saying is that this dominant C prime, okay, that is able to see all the colors, it is masking the effect of the this dominant C, is masking the effect of the C prime, which will make the person colorblind. Okay, so maybe Dr. R.C. Lalu, maybe he has recessive genes for colorblindness together, the alleles, instead of becoming like this, no, which will still make the person see color. All right, so there are some very dangerous, harmful traits that will be masked, okay, by the recessive, they will be masked by the dominant one, okay. So let's read out. The phenomenon of dominance is of practical importance as the harmful recessive characters are masked by the normal dominant characters in the hybrids, okay. In human being, a form of idiosyncrasy, this note is so funny, means stupid people. They have recessive genes. I don't think you should write this. A form of diabetes, hemophilia. No, hemophilia is a disease where your blood doesn't clot. Okay. So some people are prone to diabetes. Some people are not prone because maybe they are having the dominant gene which is not prone. Okay. These recessive characters, they will show if it is in, if the alleles are in the homozygous recessive nature. Okay. So a person that is having the hybrid for these characters will be perfectly normal. Okay. So even if he has diabetes gene, if he has hemophilia gene, no, not like that. If he has diabetes gene and if he has hemophilia gene, if he has a normal trait, no, in the homozygous dominant, no, like this, okay. If he has diabetes allele and hemophil allele, if they have the dominant form which will give them the normal appearance, they will be perfectly all right. Okay, but if the person has the homozygous recessive pairs of the alleles, they will be both diabetic and hemophilic. So these are very, very bad, very, very harmful genes. Okay. So these harmful genes, they can appear for many generations, but they will be completely masked, and the person's and his generation or her generation will be fine. Okay. So there are some exceptions to the law of dominance. Okay. It is the law of incomplete dominance. So after Mendel, there were many scientists who saw that the F1 hybrid showed a blend. Okay, instead of purple and white flower, they found a pink flower, something like that. Okay, it was a blending of the characters of both the parents. So these hybrids were found to be midway between the parents. This is known as incomplete dominance or blending inheritance. Okay, it means that the two genes of the alleles, okay, they are not related as dominant and recessive, but each of them are equally dominant, okay, or partially expressive or partially recessive. Okay, equally dominant or equally expressive, whatever you use the term. So for example, that 4 o'clock plant Mirabilis, when a red flower is crossed with a white flower, we will get pink flower. Okay, the hybrid will show itself. Okay, and then when they are self-pollinated, you will get pink also, red also, white also. Okay. Okay, now let's go to the second law, that is the law of segregation. So I hope incomplete dominance and dominance is clear.